Okay, let's keep on going. Here's number 29. So for number 29, we want to talk about first the domain. So that is part A. So part A is to find the domain. So for the domain for this one, it is all reals, or in other words, negative infinity to infinity. The range is the outputs that got used up. I think it's pretty clear that the lowest output we ever get is 0, and it goes all the way up to positive infinity. Because remember in the directions that it says, assume that this graph goes on forever. So part B, we know that the x-intercept is where y equals 0. I think you see two dots right here and right here, where y is equal to 0. So it seems like negative 1, 0, and 1, 0. Part C, we know that the y-intercept is where x equals 0. So in this case, it looks like that is the only place where we have an y-intercept. So that would be 0, 1. Now we want to know on what intervals is the function increasing. Well, I think as you walk from left to right, you can see that it's increasing in here. That would mean for these x inputs. So from negative 1 to 0, and then again it's increasing here, right? Well, that would be for these x inputs. So that would be from 1 out to positive infinity. And then where is this thing decreasing? It looks like it's decreasing here, so that would be for these x inputs. In other words, from negative infinity all the way up to negative 1. And then it's decreasing again for these inputs, or that part of the graph, from 0 to 1. Right? F, where is it constant? It is constant nowhere. G, is this thing symmetric? This thing is symmetric with respect to the y-axis. If it's symmetric with respect to the y-axis, that means it is even. All right. So that was number 29. Let's do 35 and be done. Here's this function. So the domain for this thing, notice it stops here because it's got a dot. So that means its domain is from negative 4 out. Oh, it stops over here too because it's got a dot. So its domain is going to be from negative 4 to 4 because this dot means it stops. What is the range of this thing? Well, that's all the outputs that got used. It looks like all of these outputs get used, right? So it seems like the range of this thing is going to also be from negative 4 to 4. So that's A. B is the x-intercept. We know that the x-intercept is where y equals 0. So the x-intercept is where y equals 0. That looks to be about here. So in other words, that would be about 1.2 comma 0. And then we know that the y-intercept is where x equals 0. That looks like it's going to be up here at 4. So that would be the point 0, 4. D, where's this function increasing? So where's this function increasing? I don't think it's increasing anywhere. So as you walk from left to right, does the function rise? No, it does not. So it's increasing nowhere. E is where's this thing constant? So as you walk from left to right, does the function stay the same value? Yes, it's constant from negative 4 to 0. That's where it's constant. That should be F, actually. Excuse me, that's part F. So I'll move that down to part F. And part E actually asks, where's this thing decreasing? And we can see that it's decreasing as we walk from left to right on this part of the graph. That means it would be for these inputs. So it looks like it's decreasing from 0 to 4. On all of these, increasing, decreasing, and constant, we only use open intervals. G asks if it's symmetric. I don't think it's symmetric, so nowhere. And H, it is neither. It is not even, nor is it odd. Even would be symmetric with the y, and odd would be symmetric with respect to the origin. Have a great day.